So the steps for graphing a polynomial function using derivatives are as follows. So the steps are to determine any discontinuities or limitations in the domain. So for example, if I have a rational function, my denominator can never be 0. If I have a root function, my root can never be a negative. So for example, my vertical asymptotes in this one I have is x is equal to 1 and x is equal to -3. Okay, so what would my domain be for my rational function that I have in the first example? What would my domain be? XER such that x cannot equal 1 and x cannot equal -3. Perfect. For the second one, I can write this as x times the square root of x minus 1. So what would my domain for my function be for x times the square root of x minus 1? X has to be greater than or equal to 1. Perfect. And now we have to determine any x or y intercepts. So for my y-intercept, set x equal to 0. For my x-intercept, I need to set y equal to 0. So this part's only for rational functions. So find any vertical asymptotes or holes by setting the denominator equal to 0 and check if the numerator is equal to 0 at these values. So what that means is that if I have q at a, this is q of x, this is p of x, my function at the bottom p of x cannot give me 0. And if a vertical asymptote exists, we need to examine what happens to f of x as x approaches these values from the left and to the right. So I need to determine my limits as x approaches a from the right of f of x. It'll give me either positive or negative infinity. And I need to determine my limit as x approaches a to the left of f of x is equal to positive or negative infinity. Okay. And then number 4 is only for rational functions. Check if the degree of the numerator is less than or equal to the degree of the denominator. If it is less than the degree, if it is, then the horizontal asymptote exists. So remember we did this last lesson. So find the horizontal asymptote by evaluating the limit as x approaches positive or negative infinity of f of x is equal to L. Or what we learned is y is equal to L. So we're going to divide each term by the highest power of x. Determine whether the graph lies above or below the asymptote. So for example, as x approaches positive or negative infinity, f of x is greater than L. So what that means, this comes from above. So we would evaluate at a very high x value, so f at 1,000. And f of x is less than L, meaning that this comes from below. Which means that we evaluate f at negative 1,000. So we're going to state the equation of the horizontal asymptote, and we get that by doing the horizontal asymptote is y is equal to L, which we have above. And then we have to find our oblique asymptote. So we do this by either doing synthetic or long division. We need to determine the end behavior by evaluating the function at x equal to positive or negative 1,000 to see if the y values are above or below the y values obtained from the equation of the oblique asymptote. So for example, some of the questions we did, we need to determine f of x and my oblique asymptote at a certain value. So if I take f at 1,000, I need to evaluate my oblique asymptote at y when x is equal to 1,000. And same with negative 1,000 We evaluate y at x when it is equal to negative 1,000. And now we will only a couple more steps, and then we'll get into the curve sketching. And then to determine any critical points, we need to find where the derivative of f of x is equal to 0, where f of x, where the derivative of f of x is undefined, and we want to determine this, the intervals of increase and decrease. We're going to use the first derivative to test whether the critical point is equal to max or min or neither. So if I have f prime of x and I have my number line over here, and I have my critical points, and it gives me a value of 0, or undefined, who knows? We have a positive and a negative. If my rate of change was 0 and it was defined at that point, going from a negative, positive increasing interval to a negative increasing interval, would we have a max or min at that point, at that critical point? If it's going from positive rates of change down to negative rates of change, would we have a positive, would we have a max or a min? Let's see. We would have a max. Okay, let's draw this. Max, 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 or positive slope, intervals of increase, and then intervals of decrease, which means that we have a max. And now to determine points of inflection, we do our double derivative. So we need to figure out our double derivative. We have our number line, we have our p-value, where it's undefined. Let's say it's plus and negative. So when we have our points of inflection, it tells us if we're concaving up and down as well. And then we need to examine the concavity changes to identify any points of inflection. And then we want to construct a scaling column chart to use all the x values, which are vertical asymptotes and critical numbers of inflection. Fill in the chart appropriately with positive, negative, and undefined, showing the intervals of increase, decrease, and intervals of concavity. And number 9, we're going to use everything and sketch that graph. So the first one, we have for each of the following functions, provide a complete analysis, and we are going to sketch. So for the first one, let's determine our domain. So what would my domain be for this function over here? XER, perfect. Step 2, I need to determine my intercepts. So for my y-intercept, I set x equal to 0, which means my f at 0 gives me negative 5, and my y-intercept is 0 and negative 5. And now I need to find my x-intercept, which means setting y equal to 0. So I get 0 is equal to x4 minus 4x cubed minus 5. We need to use factor theorem to determine my x-intercept. So if I use factor theorem here, what would my x-intercept be to give my whole equation equal to 0? It's a very simple number. So using factor theorem from last year, which is finding factors of 5, what x value gives me the function to be 0? It's a very simple number. Let's see if you can figure this out. Was anyone able to figure it out? Positive 1 would not. Positive 1. Would positive 1 work? Negative 1. Negative 1 would work, I believe, yeah. So my x-intercept would be at negative 1 and 0. So the reason is because we get negative 1 to the 4 minus 4 times negative 1 cubed minus 5, which gives me 1 plus 4 minus 5, which gives me 0 is equal to 0, which means that it is my x-intercept. Perfect. Because of my equation, do I have any vertical asymptotes? Do I have any vertical asymptotes? No, we have none. Which means I also do not have any horizontal asymptotes, which also means I have no oblique asymptotes. Now we need to figure out my critical points, which means I need to take my derivative of f of x. So I get f prime of x is equal to 4x cubed minus 12x squared, and that would be it. Is there anything I can factor out from my binomial? $4x squared. So equals to 4x squared times x minus 3. And remember, I have to set my derivative equal to 0, which means that my x values are at 0 and positive 3. So now I have to make my number line for my f prime of x. So I know that at 0, my graph is 0. My rate of change is 0, which means either max or min. And at 3, I have another 0, which means I'm either at a max or a min. If I sub in a number that's less than 0 and plug in negative 1, I'm going to get a interval of decrease. If I plug in a number from 0 to 3 in my derivative, I also get an interval of decrease. But if I plug in a number that's higher than 3, I get an interval of increase, which means that my f prime of x, that my f of x increases from the interval 3 to infinity, and the interval of f of x decreases from negative infinity to 0 in union with 0 and 3. So based off of this, do we have any maxes or mins in our graph? Look at the intervals of increase and decrease. Do we have a max or min? So 3 has a min. So we have a min at f of 3. So now I need to plug in f of 3 in my original function, and I get a value of negative 32, which means that my min happens at 3 and negative 32. And now what I have to do next is I have to figure out my points of inflections, which means I need to take my double derivative. So my double derivative, or my second derivative would be 12x squared minus 24x. Can I factor out anything from 12x squared minus 24x? $12x. Remember, I have to set my double derivative equal to 0. So I get 12x, and what remains in my bracket is x minus 2. So I get x is equal to 0 is one of my inflection points, and x is equal to 2. So now I'm going to draw my sign chart. I'm going to have it at 0 and at 2. So remember, these are all defined, which means that I have a point of inflection at those values. So if I sub in a value in my second derivative that is less than 0, which is -1, I will get a positive. So remember, my second derivative tells us if I'm concaving up or down. If I have a positive in my sign chart, does that mean concave up or down? Am I concaving up or down from -infinity to 0? Up. So I'm concaving up. If I plug in a number between 0 and 2, I get a negative, which means I'm concaving down. And after 2, I will be concaving up, which means that I need to figure out what my values of f at 0 and f at 2 is for my points of inflection. So we know at f at 0, that gives me -5, which means my point of inflection is 0 and 5, -5, but also I need to figure out what f at 2 is. So I sub in 2 for my original function, and I get -21. So my POI, points of inflection, is 0, -5, and 2 and -21. Now I can determine that my graph is concave up in the interval -infinity to 0 and in union with 2 to infinity. And my graph is concave down at 0 and -2. Is everyone following so far? Any questions? We're just literally taking every single thing that we've learned in the past 2 days and putting it all together. Is everyone good? Is this easy to follow? Once you get more and more practice into it, it becomes easier. The only thing that is probably going to be the hardest thing here is making sure you derive your function properly. Because if you don't derive it properly, you're going to probably mess up your graph. So now with that said, I am able to figure out how to graph this chart. So let's figure this out. So we know my y-intercept is at 0 and -5. And from our previous page, 0 and -5 is also considered to be a what? Point of inflection. This is also my POI. My x-intercept I have is at -1 and 0. I have my min at 3 and -32. And I have my POI also at 0 and -5, but also at 2 and -21. So this is everything I need to graph my chart. But we should also include our sign charts for our intervals of increase and decrease. So f prime of x, then I have f double prime of x. So I have 0 and 3, and I have 0 and 2. So now what I'm going to do is I'm going to plot my important points. So I'm going to pull out my -1 and 0 here. Okay, I'm going to plug in my -5, which is also a point of inflection. My other point, which is 2 and -21. And my min, which is at 3 and -32. So I need to use the information. That's fine. Don't worry, man, Roop. I'll just fix the attendance. Give me 2 seconds. So remember, my graph is decreasing from 0, from -infinity, all the way to 3, but it's concaving up from -infinity to 0, and is concaving down from 0 to -2. So I'm going to have it over here. So again, point of inflection. So as you can see, from -infinity to 0, this is concaving up because of this thing over here. From 0 to 2, it is concaving down. So with this thing over here, it's concaving down. And then from 2 to infinity, it is concaving up. And my points of inflection were at 0 and at when x is equal to 2. Is everybody good with this? Yes, no, maybe? All right, perfect. And now what we're going to do is we're going to hit a rational function next. So I have my f of x is equal to x over x squared minus 4x plus 4. So automatically, let's try to factor my denominator. If I were to factor that simple trinomial, what would I get when I factor it? So what do I factor? How can I factor x squared minus 4x plus 4? What does that trinomial factor into? X minus 2, x minus 2. Perfect. Or in other words, we just get x is equal to x minus 2 squared. So now I need to figure out my first thing, which is my domain. So what is my domain for my rational function over here? So domain, we know it's XCR, but we have a condition. What is that condition? X cannot equal to 2. Perfect. Number 2, we need to find my y-intercept, which means setting x is equal to 0. And if I set x equal to 0, I get a y-intercept of 0 and 0. Now I need to find my x-intercept. When y is equal to 0, so I get 0 is equal to x over x minus 2 squared. Cross multiply, I get 0 is equal to x. Which means I really don't have, which means my x-intercept is also my y-intercept, okay? Which is why it passes through the origin. And now 3, I need to figure out my vertical asymptote based off my denominator. So what is my vertical asymptote? 2. Because I cannot cancel anything from the numerator and denominator, that means that there is no hole at x is equal to 2. However, now I have to take my limits as x approaches 2 from the right of f of x. So we need to figure out what that equals. So I need to take f at 2.01. What does f at 2.01 give me? Does it give me a positive or a negative number? So I get positive on top and positive on the bottom, which means I'm approaching positive infinity. The limits as x approaches 2 from the left of f of x will also be positive infinity, because any number squared that is negative will always be positive. So f at 1.99 is a positive over a positive. Now I need to figure out my horizontal asymptote. So in this case here, when I do my horizontal asymptote, I'm just going to get 0 over 4. And that's just going to give me 0. So y is equal to 0 is my horizontal asymptote. And this was from, I think, the last lesson. So I need to determine what it's doing at my horizontal asymptote from above and below. So if I sub in f at 1,000 in my original function, I get 0.001, which is bigger than 0. So is my graph approaching my vertical asymptote from above or below? So if 0.001 is bigger than 0, is my graph approaching my horizontal asymptote from above or below? Above. And then I take f at negative 1,000, and that gives me negative 0.001, which is less than 0, which means I'm approaching my graph from below. Now I have to figure out if my horizontal asymptote, if I cross it in the graph, which means I have to set my whole function equal to 0. So HA crossing happens when 0 is equal to my function, because that's my horizontal asymptote when y is equal to 0. If it was something like y is equal to 1, I would put 1 on the other side. But when I cross multiply, I get 0 is equal to x. So it crosses my horizontal asymptote at 0 and 0. Okay, so let me repeat that again. If my horizontal asymptote was a different value, such as 1 or 2, I would just sub in 1 or 2 for my y, and then cross multiply and see at what x value that happens at, and then sub in that x value and check what y value my function gives me. So for number 5, we have no oblique asymptotes. Happy face. Which means that now I finally get to my critical points. Oh my gosh, all that work and we're still only at critical points. So my critical points, again, I have to take my derivative of f of x, which is equal to negative x plus 2 over x minus 2 cubed. So what I would do here is the product rule and the power of a function rule. So I take my denominator and make it a negative exponent, and then find my derivative using that. So my f prime gives me 0 when x is equal to -2. And I'm going to show you how that happens. So I get 0 is equal to -x plus 2 over x minus 2 squared, or cubed. Cross multiply, so this cancels out, which means I get 0 is equal to -x minus 2. Move the x over, and I get x is equal to -2. And I also know that my derivative is undefined when my denominator is 2, when x is equal to 2. So now I can draw my little sign chart. So we have a -2, which gives me 0, and I have a 2, which gives me undefined, because that is where my vertical asymptote is. So if I sub in a number that's less than -2, I get an interval of decrease, then an interval of increase, and an interval of decrease. So is there anywhere that I have a max or min at? Do I have a max or min anywhere? Remember, if there's a change in thing, so we have a min at 0. Thank you, Priyanshu. Not a min at 0. -2. There we go. So we need to take f at -2, and that gives me -1 over 8, which means my min is at -2 and -1 over 8. So my graph of f of x is decreasing from -infinity to -2, and from 2 to infinity, and f of x is increasing from -2 to +2. And now, last but not least, I gotta figure out my point of inflection. So I'm going to take my double derivative, which is 2 times x plus 4 divided by x minus 4 to the power of 4. So when I set my f prime of x equal to 0, that's going to tell me when my when a point of inflection happens. So at 0, so f prime double prime is equal to 0 when x is equal to -4, which is my numerator, and then it is undefined when x is equal to 4. So my point of inflection happens at 0. Oh, -4, sorry, it happens at -4. That was my mistake. My only point of inflection happens at -4, which means f at -4 gives me -1 over 9. So at -4 and -1 over 9 is my point of inflection. Now I need to determine my concavity. So I have -4 and 2. This is undefined because of my vertical asymptotes. And this should be 2. My apologies. And -4, 0. When I sub in a value that it's less than 4, I get concave down, and I go concave up, and then I go back to concaving up, which means I'm increasing again after my minimum. So I concave up between -4 and 2, ending with 2 and infinity, and I concave down from -infinity to -4. So now I can figure out my graph. So I'm going to plot my points first. So I have an x-intercept and y-intercept at 0, 0. I have my vertical asymptote at x is equal to 2. I have a point of inflection at 4 and -1/9. And I have a minimum at -2 and -1/8. Obviously, this is a bit exaggerated because -1/8 and -1/9 are probably closer than they seem. So I know that from -infinity to +4, I'm concaving down. Okay? And then I'm concaving up and always increasing. And then over here, it is an interval of increase and it is concaving upwards. Okay? So that's how you would graph this rational function. Everyone following? No tears yet, no crying. Feels like this is a pretty stress-free unit as you guys are channeling your inner art skills in the form of graphing some functions. Perfect. No complaints today. Beautiful. So obviously you're gonna have to take all of this in. We're gonna do one more example and that will be it for this unit. And then I'll be creating your assignments, hopefully finish it by today, then upload it tomorrow. So we want to sketch a curve just satisfying the following conditions. So I have my limit as x approaches plus and minus infinity is equal to -4. I have my limit as x approaches 5 is equal to -infinity. And I have my horizontal asymptote is crossed at x is equal to 3. So I have my x-intercepts at -6 and 0. And my intervals of decrease are between -3 and 5. My intervals of increase are between -infinity and -3, and 5 all the way to infinity. And then I have my double derivative, and that gives me a value of 0 when my double derivative is evaluated at -6 and 3, which means that I'm concaving up when x is less than 6 and between 0 and 3, and I'm concaving down when x is between -6 and 0, between 3 and 5, and bigger than 5. So this is what your skinny chart would look like. You have your critical points. You have -6. You put them in order. You have -3, 0, 3, and 5. So in our first derivative, based off our characteristics, it says I'm increasing when x's are less than 3. So this is positive, 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 which means I also have a 0 over here. And it's going down between 3 and 5, -3 and 5. And at 5, I have it as undefined because of my concavity and my horizontal asymptote and my vertical asymptote. And if I look at my double derivative, I'm concave up over here. This is 0, which is a point of inflection. Negative concave down, concave down, which means this is a max over here. 0 concaving up, then 0. So now I can draw my graph. So here I'm concaving up, concaving down. Oops, because there's a max, I'm concaving down the other way. Concaving down, concaving down. I have a point of inflection here. I'm concaving up, point of inflection, concaving down. This is my vertical asymptote, and I'm concaving down. So you can use the sign chart, or you can use the way we did it already, which is just going based off each thing separately. So I have a point of inflection at -6. I have a max at 3. -3, somewhere over here. Then I have a point of inflection here. And then I have it at 3. So what we're going to be doing is so the limit as x approaches plus and minus infinity of f of x is equal to -4, which means we have a horizontal asymptote at x is equal to y is equal to -4, sorry. So I'm going to draw my graph, concave up, concave down, concave down, concave up, cross the points and go all the way down. And then my other part would look like this. So again, you can choose to use that skinny sign chart if you want. If not, we can just do it the way we've been doing it all along, but just doing everything separately. But this is the end of the curve sketching unit, okay? So like I said, oh, I just added that as a point of inflection, sorry. It should be towards the bottom. That was my bad. I'm just showing it that it crosses, but it would not be included. So your crossing of the horizontal axis happens over here. I'm just showing it so that I'm showing you guys the point at where it crosses right here. I was just showing it for graphing purposes. That's where it would cross.